values are, I can correlate given data with this diagram. This numerical is totally based on stress strain curves. Okay. Given values are like this. First, what is gauge length? Now, what do you mean by gauge length? Let us first understand. If this is a specimen, the specimen of this luteum is something like this. The specimen is, it is standard specimen. Dimensions are specified in the standards. Okay. So specimen is like this. Initially we make 2 marks. Before putting the specimen in the luteum, we make 2 marks which are just on the either side of this slightly lesser dimension. Okay. So these 2 marks, the distance between these 2 marks is called as gauge length. In our terminology, we can call it as original length. We can call this as original length. Okay, so instead of gauge length, I am writing now L is equal to 200 mm. Original length. L is original length. Okay. Second, load. Now 40, 42, 61, 63. Can you make out which are these values? Initial load is 40. When load is 40, what is the deformation or elongation? 0.25 millimeter. So what is the material property? That means up to this load and up to this elongation, material is elastic. It is this point. That means the load at point 1 is given and the load at elongation at point 1 is also given. Have you understood this? Are you understanding or not? Load at point 1 and elongation at point 1. Load is 40 kilonewton and corresponding elongation is 0.25 millimeter. Okay. What next? Then you can go to this. At point 2, load is 42 and corresponding elongation is 26. It is yield point. That means if you want to calculate this property, which property? SYD, you have to use this load and this elongation. Okay. Next, 61. Now you can see. Here please make one correction. You make this as 63 and this as 61 because that is maximum load. What is given here? Maximum load. Maximum load cannot be lower than other value. 63 and 61. Okay. So what is maximum load? Which point? Which point in the diagram? Point B. At point B, load is maximum. So from this, you can get which property? Sigma ut or SUT. Okay. And lastly, at point 4, when fracture occurs, that time load reduces. That value is 61 and corresponding elongation is 50. That means at the last point, before breaking, what is the maximum length of the material? What is maximum elongation? That elongation is 50 millimeter. Okay. Let us calculate one by one. So first SYD, right now. SYD or sigma YD. Let us follow only one notation. Up till now we have used sigma notation. So let us use sigma. So sigma YT. You write in words. Yield strength in tension. Yield strength in tension is equal to load at yield point upon original cross sectional area. Stress is what? Load upon cross sectional area. So what will be stress at yield point? Load at yield point upon original cross sectional area. Okay. So what is load at yield point? Load at yield point is how much? This is yield point 42. Value is given in kilonewton. We have to convert it into newton. So 42 into 10 raised to 3 divided by area. Original cross sectional area. What is original diameter? Original diameter is given 16 millimeter. Okay, so what is original cross sectional area? 5 by 4, 16 square. Do this calculation and tell me the value. How much? I want everyone to use calculators. Therefore, sigma yt is equal to 208.89. What is unit? Unit. We have solved so many numericals. Newton per mm. This is yield stress in tension or simply yield stress. Second, we have to find sigma ut. Now tell me which value of load will you use for sigma ut? Maximum load. Sigma ut is equal to, yes, load, write down, load at ultimate point, load at ultimate point upon original cross sectional area. What is value of load at ultimate point? That is maximum load. What is it? 63. Sigma ut is equal to 63 into 10 raised to 3 kilonewton to Newton upon 5 by 4 d square. Are you all doing calculations or not? Sigma ut is equal to 31 point Newton per mm square, or you can simply call it as Newton per mm square is also called as mega Pascal, MPa. Okay. Then what next? Third is Young's modulus. How will you calculate Young's modulus? Young's modulus E. E is equal to stress upon strain. But which stress and which strain? That is important because we have got so many load values, so many elongation values. इनमें से कौन सी यूज करनी है? Yes, can someone tell? Read the statement of Hooke's law. You will get answer in Hooke's law. Do you have Hooke's law statement with you? Both of which kind of? Next. Do this. Hooke's law statement. Okay. Within elastic limit, stress is directly proportional to strain. So where is the elastic limit? 0 to 1. That means Hooke's law is applicable only in this region. You cannot apply Hooke's law in plastic region. That is the meaning. Have you understood it or not? Hooke's law is applicable only in elastic region. It means that stress is directly proportional to strain only in region 0 to 1, and hence you can find out stress value and strain value only in region 0 1. You cannot use any other value after point 1. Is it clear? That means we have to find stress at point 1, because up to point 1 material is elastic. So stress at point 1, strain at point 1, take ratio of that, that will give you value of Young's modulus. Okay, so write down stress at 1. Stress at point 1 is equal to, calculate stress at point 1. Stress at 1, load upon area. What is point 1 and what is the value? At point 1 value is this 40 because material is elastic up to point 1. So we have to use this value 40 into 10 raised to 3 upon 5 by 4 16 square. Now you can see we have to use area everywhere. So better you calculate area separately initially and use that value everywhere. No need to every time do these calculations. So what is the value? 190.94 up to 2 digits Newton per mm. This is stress at 1. Now strain at 1. Strain at point 1. Epsilon L is equal to, at point 1 how much is the elongation? Those you are not understood. At point 1 मतलब ये point मतलब elastic region. Is it clear?
Yes sir.
So at point 1 how much is the elongation?
0.25.
0.25. You have to use this value. That's why I am saying pay attention. Some of you are not behaving properly. फक्त एकच होता मी इग्नोर करीन, नंतर माझा वे आहे माझ्याकडे. Okay? Elongation is this much. Delta L upon L. What is delta L? 0.25. What is original L?
200.
Original L is 200. So 0.25 upon 200. That is equal to
1.25 minus
1.25
into minus 3.
minus 3. What is unit of strain? Last bench. Last bench, stand up. Yes, so unit. Unit of epsilon L. You tell me. तुम्ही दोघी सांगा. हाँ. Strain का unit. Unit test. Stress का unit. Newton per mm sir. Okay, sit down. So this is strain obtained. Now how to find E? We have to now obtain Young's modulus E. So how to get it? Using E is equal to stress upon strain. Stress is 198.94 upon 1.25 into 10 raised to minus 3. This will give you value of Young's modulus, which is 159.16 into 10 raised to 3 Newton per. This is Young's modulus. This is again important problem. So we have calculated 3 important properties. One is yield strength or yield strength, which is 208, ultimate strength, which is 313, and Young's modulus, which is 159 into 10 raised to 3 Newton per mm. Continuing with yesterday's numerical. Percentage elongation and percentage reduction was also to be calculated. We calculated 3 values: yield, stress, ultimate stress, and Young's modulus. Okay, now percentage elongation, how to find? Final length tell me what is final length? LF minus LI or LI into 100. What is the value of final length? See the table. In the table it is given. In the table, just see last row. 50 is elongation. It is not final length. What is original length? I can call final length is equal to original length, which is 200 gauge length plus elongation, maximum elongation plus 50. That is equal to 250 millimeters. This is final length. Have you understood? Original length plus elongation is the final length. Original length is this much, इसमें और elongation हो गया, that is final length. Okay. Initial length 200. Initially bar length was or gauge length was 200. Okay. Putting both the values, we get percentage elongation is equal to 250 minus 200 upon 200 into 100. 25. Percentage elongation equal to 25%. Is it clear? Next is percentage reduction in cross-sectional area. Okay, so next is percentage reduction in cross-sectional area is equal to. Now, which area is minimum and which is maximum? Initially, area is minimum or maximum? Initially, maximum. When you increase the length, area decreases. So initial area is maximum, and we have to find reduction. So how will you find reduction? Initial area (AI). I am just writing in the form of rotation. Initial area minus final area upon initial area into 100. Okay. Initial area (AI) is equal to pi by 4 d square. What is initial diameter of the rod? Diameter was 16 millimeters. So pi by 4 16 square. ये हो गया initial cross sectional area. Take the value 5.2006 millimeter square. अभी फाइनली क्या होता है जब फ्रैक्चर होता है मटेरियल तो क्या होता है लेंथ इंक्रीजेस बट एरिया गोज ऑन डिक्रीजिंग ओके सो फाइनल एरिया is equal to pi by 4. Now which diameter will you take? Final diameter is it given somewhere in the statement? Just check. I want answer of this question from you. Final diameter. Which diameter you have taken?
Diameter at neck.
Diameter at neck. Neck मतलब क्या?
Elongation के बाद.
At the end, initially the bar is like this. Again I repeat in brief. Initially the bar is like this. We are applying which force? Tensile force on the rod. Okay. जैसे बार का लेंथ इंक्रीज होता है, diameter goes on reducing like this. At one stage what happens? Diameter becomes minimum. ये क्या है? This is called as neck formation. Okay. अब इसके बाद और अगर उसको अप्लाई करेंगे फोर्स तो ये क्या होता है यहाँ पे ब्रेक हो जाता है. Is it clear? So diameter at the neck is the minimum diameter. Is it clear? Diameter at neck is minimum diameter. That's why final cross sectional area is pi by 4 into minimum diameter or diameter at neck. 8 square. Pi by 4 means 10 square. Pi by 4 10 square
78.
equal to
78.5.
78.5 unit is square, mm square. And putting both these values in our equation, percentage reduction is equal to 201.06 minus 78.5 divided by initial, not 78, 201.06 into 100 equal to 60.93. Some of you might, if you use up to 4 digits and if you round it, you will get different answer. But around 60 is okay. 60 answer with me 60.93. Okay. So every answer carries 2 marks. Total 10 marks. Question can be framed on this.